Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to dig deeper into this idea of spatial data by talking about the differences between discrete spatial data and continuous spatial data, and what the spatial part of spatial data actually means. Let's go ahead and give ourselves a little bit of room here. And we're going to be talking about the spatial part. The spatial part of spatial data. So what do we mean when we say the spatial part? Well, generally speaking, in order for something to be spatial, it has to be referring to a location. Right, this means it refers to a location. Right, and we already know how to get locations, right? We've talked about this back with the idea of GPSing. We talked about it with the idea of georeferencing, right? So we should hopefully be pretty comfortable with that idea of location. And when we talk about it in specific, what we're generally referencing is a set of coordinates of one or more coordinates, right? And so if these are in terms of lat and long, right, where these are angles, then this is going to be projected coordinates, or sorry, this is going to be geographic coordinates, which is 3 dimensions, right? And if we have an x and a y, or you'll sometimes see this referred to as easting and northing, right? These were their measurements, right? Some amount of feet or meters or whatever away from an origin, right? These are projected coordinates. Right? Geographic coordinates represent location on a 3D globe relative to a meridian and an equator. Projected coordinates are usually dealing with an x and a y relative to an origin. So this is going to be sort of more like dealing with Cartesian coordinates. And we're going to be spending most of our time, and most of our examples are going to come from this projected coordinates setup when we refer to location. So when we talk about the spatial part, once we know that we're talking about coordinates, either geographic or projected, the next thing that we need to describe is the types or categories of spatial data. Right, there are categories of spatial data. And you can think of these broadly as being discrete and continuous. So discrete spatial data is anything that has a defined boundary. Right? And so a good example of a discrete spatial data set might be the property boundaries for houses in your neighborhood, right? If you've ever dealt with housing, hopefully you know that there's a survey that underlies each house that describes the location of the boundaries of the lot, right? And so we can, and we have, and we will be able to draw those out in a GIS using lines that represent the edges of that boundary to form a polygon, right? And then maybe next to it we have another polygon that maybe is shaped slightly differently, right? Maybe we have these houses border a cul-de-sac, right? So there's a circle in the middle, right? These things all have clearly defined boundaries that make them up, right? We can say, hey, this thing starts here, it ends here, it has this shape, right? That means that it is discrete because it has a clearly defined boundary. Another category of spatial data is what's called continuous. And so if discrete data has a defined boundary, then continuous data would be things that change continuously over their range. Right? Anything that changes continuously over an area. Right? So a good example of continuous data would be something like elevation, right? It's like if you were to be walking up a hill, for example, right? Every step you take, you're changing elevation, right? You've either stepped up the hill or you've stepped down the hill. But very rarely, or for very, very short time periods, are you ever standing at the same height. And especially if you consider microtopography, right? Because things that we may as humans perceive to be the same, right? If you really measure, right, 1 or 2 centimeters difference, that's still change. Right? So continuous data is anything that changes over an area. And so just to recap our examples for discrete, right? Good examples are political boundaries, right? Things like building footprints, right? Lake outlines, right? Because if you think about a lake, it has a clearly defined boundary where the water stops. Right? Continuous, things that change over an area. Common examples of this include elevation. Right? Another example of this is going to be climate or weather. W-E-A-T-H-E-R, weather. Right? Again, think about when you see weather maps, right? Precipitation it's not static over space. It changes across the area. Okay? So discrete, defined boundary, continuous, changes over area. Hopefully this makes sense. In the next video, we'll talk about how we actually represent discrete spatial data using coordinates. And then the video after that, we'll talk about how we represent continuous data using coordinates. So as always, if you have any questions, please reach out. Thank you.